King stuffers. All right, everybody. All right, we have an exam a week from today, right? Pardon?
Today's Tuesday.
Tuesday, next Tuesday.
Oh, I thought you said Wednesday.
No. A week from today, we have our third exam, right? And I sent out a review.
Yesterday.
Was it yesterday?
Yes, it was yesterday.
On the lecture last time, I said, I'm going to send it out. Someone email me if I don't send it out. And no one emailed me, so I forgot about it. But you have it now, right? And the review is not a complete review. There's some stuff that I still may cover today and tomorrow. So anything we do this week could be on the exam. Okay, let's start with what we did last time. We're talking about sum and difference formulas. We're not done with this section. Hey. You ready? Okay. We're doing sum and difference formulas. Also, the video from last class, I had a problem with it, but I was able to salvage it, and I just posted it today. So, just so you know, I thought I had lost it, but I was somehow able to recover the data. Okay, sum and difference formulas from last class. We talked about the sum and difference formulas for sine and cosine. And I want everyone to take the formula sheet I just passed out. And I want you to make sure you know where those are on this formula sheet. Bottom left-hand corner, right? You see the ones for sine of alpha plus beta, sine of alpha minus beta, cosine alpha plus beta, cosine alpha minus beta, right? You have those formulas. What we did not do was the formula for sum and difference for tangent, right? So you have them there, but I'm going to write them down. Tangent of alpha plus beta. So you see the formula there? I want to show you where that formula comes from, all right? All they're doing here to get that formula is they're rewriting tangent of alpha plus beta as sine of alpha plus beta over cosine of alpha plus beta. Right, that's what tangent is, right? Sine over cosine. And then we have formulas for both of these, don't we? So if I continue writing this, sine of alpha plus beta off of this would be sine alpha cosine beta plus cosine alpha sine beta, right? I want to make sure I write it in the same order they do, okay? And then on the cosine alpha plus beta, it's cosine alpha cosine beta. And then remember with the cosine, it's the opposite of what was there, right? So it's minus, not plus, sine alpha and then sine beta. Right, now somehow, according to this formula sheet, that turns into, let me write down what the formula sheet says this is. Right, it says tangent of alpha plus beta is tangent alpha. Oop, whoa, where'd that come from? Tangent alpha plus tangent beta over, and then we have here 1 minus, it's the opposite, tangent alpha, tangent beta. Now this is one of those formulas, this one of those formulas that I don't even have this one memorized. These two I pretty much have memorized. This one I don't even memorize. I just know that there's a formula for it, and you should probably treat it the same way. Know that this formula exists on your sheet. Because most of the time when we have this, we turn it into this. But we can just go straight here. So how do you think we could get this to be this? So let's think about this. Look at the numerator here. This is almost like an identity. This is almost like an identity problem. Can we turn this into this? So look at the top left corner, tangent alpha. How would you turn this into tangent alpha? What would you need to turn this into tangent alpha? What would you need underneath the sine alpha? A cosine alpha. So I'd have to divide by cosine alpha, and I'd have to get rid of that, right? Right? So could I be clever and do this? Could I take this entire thing and multiply by 1 over, we said we needed a cosine alpha on the bottom of that, right? And we need to get rid of the cosine beta. Could I do that on the top and bottom? I know that that's not a very natural thing to want to do, but could I do that? Yeah? And then I'm going to distribute this here and here, and then this one will go here, and this one will go here. Y'all see what I'm doing? What happens when I do this times this? I'll go ahead and write it down. I'll have sine alpha cosine beta. That's the top, right? But now I've multiplied by 1 over this, so this will become, or will go on the bottom of it. Cosine alpha cosine beta. Then plus, now I do the same thing here, cosine alpha sine beta over cosine alpha cosine beta. Any questions there? That's distribution through the numerator. All of that divided by, and now we do this here and then here. Cosine alpha cosine beta over the same thing, right? Cosine alpha cosine beta. That's this to this. Then minus sine alpha sine beta over cosine alpha cosine beta. And now a bunch of things are going to start canceling out. Any questions? All right, what goes away here? That's gone completely, right? Over here, that's gone completely. This and this cancel. This is a 1 right here, right? Because they're the same exact things. And then here, does anything change? No, right? Nothing goes away, right? So what's left? What's that? Tangent alpha. Plus, what's that? Tangent beta. Right? Tangent alpha plus tangent beta. Yes? Yes?
So when you multiply and you divide, that's when you're able to take out the common, like how you did the cosine beta.
Yes, when you multiply is when you can cancel. Is that what you're asking?
Yeah, when you multiply and divide. So you can't do it when you add or subtract.
That's right. So this bottom left becomes a 1, right? That's the bottom left over there. And then over here, we're left with sine alpha, or sine alpha over cosine alpha, which is tangent alpha. And then sine beta over cosine beta, which is tangent beta. All I'm showing you here is that this formula here comes from doing these two formulas from last class, simplifying it or changing it, and making it look like this. Okay? And then there's another formula. If we change this to a minus, if we change that to a minus, how does this formula change? Yeah, this is a minus and that's a plus. That's the only difference, right? So if that's a minus, then this will become a minus and this will become a plus. All right, so all I need for you now is just to make sure you know that those formulas exist, okay? And then we can use them. Questions, questions? I'm going to do a problem. By the way, I've opened up 8.5 and 8.6 homeworks back on the online system. I've made them due on the 8th, which is a week from today, so right before the test. That's 8.5, 8.6. So by the time we get to next Tuesday, you should have everything you need to complete those homework assignments. I know for 8.5, I gave you a few problems at the end of class last time, but I didn't give you the entire section. In addition to that, you'll have the homework from the online system. Am I clear? The reason I wanted y'all doing the handwritten out of the book was for the solving equations and for the identities. Those were the two sections I wanted you to be working by hand. Now we'll go back to the computer for a while, all right? Okay, let's do a problem here. So let's say we wanted to, which one do I want to do here? Yeah, we're going to pick up from last class here. What if I tell you this? Say you're given here that tangent of alpha is -4/3, and I tell you that alpha is between pi over 2 and pi, and then I tell you that sine of beta, some other angle beta, is √3/2, and that beta is between 0 and pi over 2. So I'm giving you some information about an angle alpha. I'm giving you the value of tangent of that angle. I'm telling you what it is, and I'm telling you where the angle lives, what quadrant it's in. Then I'm giving you some information about beta, telling you what sine of beta is. That's a different angle, right? And I'm telling you where beta lives. And from that, I'm going to ask you all of these questions. I want you to find part A. Let's find sine of alpha plus beta. Then for part B, let's find cosine of alpha minus beta. And then for C, let's find tangent of alpha minus beta. In your homework, they ask for a few more of these, but I think if we do a couple of these, you get the idea. If you go back to last class, this is the type of problem we did at the very end. We were working on problems like this. Does anyone know what I'm going to do now? If I want to find out what this is, right? I have a formula for that, don't I? The formula is that is what? Sine alpha times cosine beta plus cosine alpha sine beta, right? So in order to figure out what this is, I need to know what sine of alpha is, what cosine of alpha is, what sine of beta is, and what cosine of beta is, right? I need all of those things. The only information I'm given is what tangent of alpha is and what sine of beta is. So I'm going to look at this as like two separate problems. I'm going to use this information to figure out everything I need to know about alpha, and then I'm going to use this information to figure out everything I need to know about beta, and then I'll use that information together to answer these, all right? So this is almost like two separate little problems we're doing here. Over here, first thing I'm going to do is figure out what quadrant I'm in. Well, I'm between pi over 2 and pi, right? So that puts me in the second quadrant. This angle, alpha, is in this quadrant. And I've given the value of tangent. Tangent, by definition, is which coordinate over which coordinate?
Y over x.
The y over x, right? So this is somehow the y coordinate. So I'm going to write it this way. -4/3 is the y coordinate divided by the x coordinate, right? So does that tell me that my y coordinate's -4, my x coordinate's and my x coordinate's +3?
No.
No, you have to be careful here because you're in the second quadrant. When you're in the second quadrant, your x is negative and your y is positive, right? That means this negative, negatives on fractions can float, right? They can be on the top or the bottom or out front. I'm going to move that negative to the bottom. And then that will now give me what the x coordinate is, right? -3, and the y coordinate is 4, and that matches up with what quadrant we're in. So I'm just going to kind of like draw an angle over here. I don't have to be precise about this, just be in the second quadrant. And I'm going to label the point x coordinate -3, y coordinate +4. -3 plus 4. And what am I doing? Why am I doing this? Where am I trying to go with this?
So you can find the R.
So I can find r, and once I find r, what am I going to do with that?
You can find cosine.
Exactly. Once I figure out what x, y, and r are, right? Right? Once I find out those three things, then I can tell you what sine alpha is, cosine alpha, tangent, secant, cotangent. I know all of them, don't I? But I need all three pieces. So now what I'm going to do is find r. So I'm going to use the good old, formula we had, right? It was x squared plus y squared is r squared. And I know what x is. It's -3 squared plus the y, which I know is 4 squared. That must be equal to r squared. That's 9 plus 16 is r squared. And then that's 25 on the left, and the square root of 25 is 5. Do I need to go through that, or is r's 5? Okay. Okay, so I have everything. So even though I may not need it, I'm going to list out like pretty much everything I now know. I now know from over here that sine of alpha, right? Sine of alpha is going to be which coordinate over which coordinate? Y over r, right? So the y coordinate we said was 4, so this is 4/5, yeah? And then cosine of alpha would be? -3 over 5, right? I don't need to write down what tangent is, do I? Because I have tangent, right? And I don't need to write down secant or cotangent because it's just all those flipped over. So those three alone should be everything I ever need, yes? Okay. Now, I know everything I need to know about alpha. Now, let's go figure out everything we need to know about beta. Then we'll put those pieces of information together to figure out these. This all making sense, how this is flowing? Yeah? All right, what quadrant are we in for beta? First quadrant, right? So our angle is in the first quadrant somewhere here. And I've got some fancy colors today. I'm given this, right? Now, look, I realize that right now you could actually tell me what beta is. Because we should all recognize root 3 over 2, right? Sine is the y coordinate. So at what angle is the y coordinate root 3 over 2?
60 degrees.
60 degrees, right? But we don't need that, okay? We're going to just stick to what we've been doing here, all right? Because over there, that's not a common point on our circle. So I'm just going to do the same thing here. I'm going to go like this. Remember that this is sine is which coordinate over which coordinate? Y over r. So I'm going to let the y be that. And does this make sense? Is your y coordinate a positive number?
Yes.
In the first quadrant? Yes, right? R is always positive, right? Okay. So I'm going to label this point. This point has as a y coordinate root 3. And then I have the r here is 2. And what I don't know is what x is, right? I don't know what the x value is. I do know that when I find it, though, it'll be positive, right? Because I'm going to be in the first quadrant. So I'm going to use the Pythagorean again. I'm going to use that and solve for x. So using Pythagorean, I know x squared plus y squared is r squared. Filling in what we have, x squared, y is the root 3. Root 3 squared must be r, which is 2. That's squared. So x squared, I don't know why I put an equals there. X squared plus 3, right? Because root 3 squared is 3, equals 4. Subtract 3 on both sides. X is 1. X squared is 1, sorry. And then, real important here, when I solve for x, I have to do plus or minus because I'm taking the square root, right? Now over here, when we solve for r, it should have been plus or minus, but r is always positive, which is why I took 5. Here, we have to think about it. The answer could be plus or minus 1. How do we determine which one it is?
Depends on what quadrant.
Depends on which quadrant you're in, right? If we were in the second quadrant right now, we would take the negative, wouldn't we? But we're in the first quadrant, so the x-coordinate has to be positive. So this is 1. X is 1. X is 1. And now, again, we have everything we need, right? Okay, let's put it all together. I'm going to do it over here, okay, because I'm going to write first what I knew over there. Sine of alpha was 4/5, because I'm about to erase all that stuff. Cosine of alpha was negative 3/5, and tangent of alpha was negative 4/3. Okay, that's from the alpha information. And then I just did everything for beta. So for beta, I have sine beta. Do we know sine beta? Well, that was given to us, right? 3/2. And then cosine beta. Now that I know what x is, right, it's x over r. So x was 1 over r, which was 2. And then tangent of beta would be y over x, which is, square root of 3 over 1, right, which would just be root 3. I'll put it over here, root 3. There we go. We have everything we need to answer the question. You see why I like these problems on a test? I mean, it's a lot of concepts that we have to bring together and understand, right? So now let's finally answer part A. If I want to know what sine of alpha plus beta is, then by definition and by formula, this is sine alpha cosine beta plus cosine alpha sine beta. That's just off my formula sheet. And I know what each of these things are. They're over there, right? So who wants to give me, what's sine alpha? 4/5 times, right? This is multiplication. Cosine beta, 1/2 plus cosine alpha, negative 3/5 times sine beta, root 3/2. Order of operations, multiplication before addition and subtraction. So I'm going to multiply those two together. I'm going to multiply those two together. 4/10. Don't reduce that. I know it's 2/5. Don't reduce it, though. What do we get here? These two numbers together, that's a negative number, right? Negative 3 times root 3? Negative. So I'm going to be adding a negative. So I'm going to put minus here instead. 3 root 3 over 10 again, right? 5 times 2, 10. Those have the same denominator, yes? Which is why I didn't reduce this. I know these are going to come together into one fraction. So this is going to be 4 minus 3 root 3 over 10. Box it up. That is the exact answer. Questions? No? And the birds sound like they're having a good day. We should, right? Part B. Cosine of alpha minus beta, right? That's what I want. So the formula here is cosine alpha cosine beta plus sine alpha sine beta. How do I know that? Yeah, it's the opposite, but it's right here, right? Right. Now, in class last time, I did not prove these formulas, right? I told you that that would take some time for me to prove these. There are proofs of these in the book. In the ebook, they do go through the proof of these if you want to try and read through the proof. And please, if you want to really see it and have it explained, just come to my office and we can sit down and spend 30 minutes going through it, all right? We are just taking these on faith. I hate doing that, but that's what we're doing, all right? So now we just fill in, right? Like once you have this, right? Once you have this, we're at the like plug and chug stage, right? We're just plugging these answers in into our formula. So cosine alpha is -3/5 times cosine beta, which is 1/2, plus sine alpha, which is 4/5, times sine beta, which is √3/2. And so we wind up getting -3/10 here, multiplying straight across, plus 4√3 over 10. And then we can put those together, -3 plus 4√3 over 10. Finally, any questions? No? Yes? No? Finally, part C is to figure out what tangent of alpha minus beta is. And that, by the formula sheet, right, is tangent alpha plus or minus tangent beta. If there's a minus there, there's what here? What is it? Minus, and then down here? Right? And we know all those values, right? Now this is going to look ugly. Let's do it though. Tangent of alpha, -4/3, minus tangent of beta, √3, over 1 plus tangent of alpha times tangent beta, so -4/3 times √3. Now that is it. I mean, that is an answer, yes? Go
I was
ahead.
gonna ask,
Is that okay?
just to put the √3 over 1.
Here?
Yeah, both of them.
Yeah, I'm going to start cleaning this up a little bit. I mean, this is, technically, that is a correct answer. It's just not really pretty. It's not really cleaned up. So I'm going to go ahead and clean that up, all right? I'm going to keep it as an exact answer. I'm not going to use my calculator, but I am going to clean it up. And to do that, I am going to look at this as being over 1, and then this as being over 1. And so if I wanted to put these two together, I would have to get a common denominator, right? So I'd have to multiply the top and bottom here by 3. 3 here, 3 there. So my new numerator looks like this. -4, take away 3√3 all over the common denominator of 3. Okay, so that's this numerator, subtracting that numerator over the two, the denominators are common now, so you bring them together, you just get 3 down there. And then here, let me go a little slower on this one. This will be 1, let me make this a minus 4√3 over 3. So all I did there was put this minus right here instead of the plus. And then I multiply 4 times √3 on top, and then 3 times 1 on the bottom. So I've got that, right? Say again? What?
Can you say that again? Sorry.
So this minus right here, I just plotted out front as made that subtraction, and then multiply across, and get this. Now I'm going to put these two together, right? So how would I rewrite the 1? 3 over 3. So I rewrite that as 3 over 3, right? Now I can put those together. So I have -4 minus 3√3 all over 3, all over 3 minus 4√3 all over 3, right? Now you have a fraction divided by a fraction, so you can keep dot flip, right? So I'm going to just forget that this is here, flip it, put it up here as a 3 over that denominator there, or that, I should say, that numerator. And now these 3's cancel. And I should be at my final answer. Negative 4 minus 3 root 3 over this right here, 3 minus 4 root 3. That's the exact answer. Let me see what this had as an answer. Oh, you know what? Did it not ask for it?
It probably went to rational.
Yeah, it rationalized it. Yeah, I'll just leave it. All right, we good? Understand? All right, we're going to move on. More problems. Still in the same section, all right? We're still in this section. Sum difference formulas. All right, I'm going to give you some information again. If I tell you that cosine of an angle theta equals negative 2/5, and I tell you that theta is in quadrant 3, find, you know what, what I want you to find, let me put it over here. Find part A. Tell me what sine of theta is. Then I want you to tell me what sine of theta minus pi over 6 is. And then I want you to tell me what cosine of theta plus pi over 4 is. And then finally, I want you to tell me what tangent of theta plus pi over 3 is. And all of these answers need to be exact answers, no decimals, right? No calculators. Let's look at what we're trying to find first. First thing I want to know is what sine of theta is, right? And I give you some information about cosine theta. So you should be able to do what we just did, right? Draw it, figure out what quadrant you're in. Well, I already told you what quadrant we're in, right? Figure it out, figure out x, y, and r. And then once you have x, y, and r, you'll know what cosine theta is, tangent theta, sine theta, right? You know everything. And so I should be able to answer the first one, right? Then I have to figure out what sine of theta minus pi over 6 is. This is just like the problem we just did. It's almost like alpha minus beta. Except one of the angles, they already tell you what it is, right? They already tell you what this is. So we're going to use the difference formula for this one, break it up. Use the sum formula for this, break it up.